In this video, I'm going to explain perspective analytics. Perspective analytics is a type of analytics that uses data, mathematical algorithms, and business rules to suggest the best course of action to take in a given situation. Unlike descriptive analytics, which simply describe what happened in the past, and predictive analytics, which forecast what is likely to happen in the future, prescriptive analytics goes a step further to recommend what actions to take based on the insights generated from the data. Prescriptive analytics can be used in various areas of business, including marketing, finance, operations, and supply chain management, among others. For example, in marketing, prescriptive analytics can help business to optimize their marketing campaigns by recommending the best channels, messaging, and timing to reach their target audience. In finance, prescriptive analytics can assist with financial planning and risk management by recommending the best investment portfolios, adding strategies, and other financial decisions. To implement prescriptive analytics, businesses need to follow a few steps are given below. The first step is define the business problem. Identify the specific problem or decision that needs to be addressed through prescriptive analytics. Second is collect and analyze data. Collect data relevant to the business problem and analyze the data to identify patterns and insights. Develop mathematical models and algorithms. Develop mathematical models and algorithms that can help to generate recommendations based on the data and insights. Test and validate the models. Test and validate the models using historical data to ensure that the recommendations generated are accurate and reliable. Implement the models. Implement the models into the business process to generate recommendations for decision making. Continuously monitor and refine the models. Continuously monitor and refine the models to ensure that they remain accurate and effective over time. So creating the data for analytics through designed experiments. So designing experiments is an effective way to create data for analytics. Here are the few steps you can follow to design and conduct an experiment. First step is define the problem. Identify the problem you want to solve or the question you want to answer. Be specific about what you want to learn from the experiment. Second is formulate the hypothesis. Develop a hypothesis that can be tested through the experiment. The hypothesis should be specific, measurable, and testable. Design the experiment. Decide on the experimental design that will allow you to test your hypothesis. This includes deciding on the independent and dependent variables, the sampling method, and control group. Collect the data. Collect the data by conducting the experiment. Be sure to record all the data accurately and clearly. Analyze the data. Use statistical analysis tools to analyze the data and draw conclusions. This may involve running tests such as t-tests, NOVA, or regression analysis. Draw conclusions. Based on the analysis of the data, draw conclusions about the hypothesis. Determine whether the data supports or contradicts the hypothesis. Active learning. So communicate the results. Finally, communicate the results of the experiment to stakeholders in a clear and concise manner. This may involve creative visualizations or reports that summarize the findings. Next, we'll see the active learning. Creating the data for analytics through active learning. Active learning is a technique used to create data for analytics by iteratively selecting and labeling data samples to train a machine learning model. Here are the steps you can follow to create data for analytics through active learning. Define the problem. Identify the specific problem you want to solve using machine learning. Determine what data is required to solve the problem. Select a small initial data set. Begin with a small initial data set that is representative of the problem you want to solve. This can be a random sample or a domain expert's selection. Train a machine learning model. Train a machine learning model using the initial data set. Select samples for labeling. Use the trained model to predict on a larger data set and select samples that the model is uncertain about to request a human expert to label them. Label the selected samples. The human expert labels the selected samples based on the problem domain and the question to be answered. So add labeled samples to the training set. Add the newly labeled samples to the initial data set to create a larger, more diverse training set. Retain the machine learning model. Retain the machine learning model with the updated training set. Repeat steps 4 to 7. Iterate through the active learning process by selecting additional samples for labeling and retaining the model until the model achieves a satisfactory level of accuracy. So through active learning, you can create a high quality data set for analytics, which will enable you to train machine learning models that can make accurate predictions and generate insights that can be used to inform decision making. Next, reinforcement learning. Creating data for analytics through reinforcement learning. Reinforcement learning is a type of machine learning that involves training an agent to make decisions based on feedback from the environment. In reinforcement learning, the agent takes actions in an environment and the environment provides feedback in the form of rewards or penalties based on the actions taken by the agent. Here are the steps you can follow to create data for analytics through reinforcement learning. First one is define the problem. Identify the specific problem you want to solve using reinforcement learning. Determine what data is required to solve the problem. Define the environment. Define the environment in which the agent will operate. The environment could be a game, simulation, or a real world scenario. Define the actions. Define the actions that the agent can take in the environment. The action should be relevant to the problem you want to solve. Define the rewards. Define the rewards or penalties that the agent will receive based on the actions taken in the environment. Rewards should be designed to encourage the agent to take actions that will help to solve the problem. Train the agent. Train the agent using reinforcement learning techniques. This involves having the agent take actions in the environment, receiving feedback from the environment in the form of rewards or penalties, and using that feedback to adjust its decision making. Collect data. Collect data on the actions taken by the agent and the rewards received from the environment. This data can be used for analytics to evaluate the performance of the agent and gain insights into the problem being solved. So analyze the data. Use analytics techniques to analyze the data collected from the reinforcement learning process. This may involve running statistical tests or building a predictive models to identify patterns and